Alright, another great use for derivatives and logs is something that's called logarithmic differentiation. Currently, if you wanted to take this derivative, you would have to use the product rule, the quotient rule, and the chain rule. And that would be quite a pain. So, what you can do first is take the natural log of both sides. By taking the natural log of both sides, one, if you paid attention in pre-cal or algebra 3, you know that you can split this up. So products get turned into addition, powers get turned into constants, and division to subtraction. So it will end up looking like this. Okay, this is much easier to differentiate. The derivative of natural log of y, because this is implicit now, is 1 over y, because it's the natural log, times the derivative of the inside, which is y prime. That's what we're actually trying to find. The first part is 1 over 2x plus 3 times the derivative of the inside, which is just 2, plus 2 over 5x minus 2 times the derivative of the inside, which is 5, minus 1/2 times 1 over 2x plus x squared times the derivative of the inside, which is 2 plus 2x. Okay, now all we got to do is simplify. 2 over 2x plus 3 plus 10 over 5x minus 2. We could factor a 2 out of this piece. And that 2 is going to cancel with the 1/2. So we're going to be left with minus 1 plus x over 2x plus x squared. Okay, and we're trying to find the derivative, so we need to solve for y prime. So y prime is equal to y times this whole mess up here. And I'll write it in just a second. So y prime is equal to our original, which the original is way up here. See if I can grab it. Of course I can't grab it. So I need to zoom so I can see it. So y, which is the original, 2x plus 3, 5x minus 2 squared over square root of 2x plus x squared times this whole derivative that we calculated. And this is actually what our derivative is. Okay, and no, I'm not going to simplify it. I'm not going to put those fractions together. It's a beast of a problem. So, there you go. Let's do one more. Okay, here's one more function that we're going to take the derivative of. It's a rational function. It's got a polynomial on top, a polynomial on the bottom. The power on top's bigger, so if we're going to infinity, it's going to go to infinity as well in some form or fashion. Let's see what else. It's got zeros at 0 and -1. It's undefined at 1/3. There's all sorts of things we can say about it, but we're going to take the derivative. I don't want to use chain rule mixed with product rule mixed with quotient rule, so I'm going to take the natural log first. Okay, logarithmic differentiation, which means I can split this up. So natural log of x plus 3 natural log of x plus 1 minus 2 natural log of 3x minus 1. Now I can take the derivative, 1 over y times y prime equals 1 over x plus 3 over x plus 1 times the derivative of the inside, which is just 1, minus 2 over 3x minus 1 times the derivative of the inside, which is 3. Okay, so this is going to be, y prime equals, I can multiply the y back over, so the y was x times x plus 1 cubed over 3x minus 1 squared times 1 over x plus 3 over x plus 1 minus 2, minus 6. 3 times 2 is 6 over 3x minus 1. Okay, this is fine. It does tell us where our derivative is undefined. It's undefined at 0, -1, and 1/3. We also know that it's 0, our derivative is 0 at 0 and -1. Unfortunately, we really don't know about this part over here. When you combine these three together, you may figure out that there's another 0,